I'm trying to figure out how many SVM models GridSearchCV trains when I use it to tune hyperparameters. I have a regularization parameter C with 3 possible values, 0.1, 1, and 10, and a kernel type with 2 options, linear and RBF. I'm using 5-fold cross-validation. To find the total number of parameter combinations, I multiply the number of choices for each hyperparameter. 3 options for C multiplied by 2 options for the kernel type equals 6 unique model combinations. Because I'm using 5-fold cross-validation, each of those 6 model combinations is trained and tested 5 times. Therefore, the total number of models trained is 6 combinations times 5 cross-validation folds, which equals 30 models. I need to understand how the parameter grid and cross-validation interact with GridSearchCV to efficiently tune hyperparameters. The number of models trained impacts the total computation time, so it's a very important thing to know. I'm tuning an SVM classifier using GridSearchCV. That means I'm systematically trying out different combinations of settings to find the best one. This is a multiple-choice question testing my understanding of how many models GridSearchCV trains during hyperparameter tuning. The question asks me to determine the total number of SVM models trained by GridSearchCV based on the given parameter grid and cross-validation setup. This answer is incorrect because it only considers the number of different values for the C parameter and ignores the kernel parameter and the cross-validation folds. This answer incorrectly calculates the number of parameter combinations but does not account for the 5-fold cross-validation. I need to multiply by 5 since the process trains 5 different models for each combination. I see this answer as incorrect because it only considers the different combinations of hyperparameters. 3 values for C times 2 values for the kernel equals 6 combinations, and ignores the 5-fold cross-validation. Each of these 6 models is trained and tested 5 times, so we're missing a crucial step. This answer is also wrong. It looks like a mistake, where someone multiplied the number of C values, 3, by the number of cross-validation folds, 5. We need to account for asterisk all the parameter combinations, not just one part of them. This is the correct answer. To get this answer, I first calculated the total number of parameter combinations. 3 values of C multiplied by 2 values of kernel equals 6 combinations. Then, I multiplied that by the number of cross-validation folds, 5 folds, giving me 30. So, 30 models are trained in total. GridSearchCV trains and evaluates each parameter combination for every fold. This specifies all the different settings, hyperparameters, we want to test. In this problem, we're changing C, a regularization parameter that controls the model's complexity, with values 0.1, 1 and 10, and the kernel type, either linear or RBF. This lists the 3 different values we are using for the regularization parameter. A lower C value means a simpler model, and a higher value means a more complex model. This indicates that we are using 5-fold cross-validation. This means our data is split into 5 equal parts. For each model configuration, we train the model on 4 parts and test it on the remaining part. This process is repeated 5 times, each time using a different part as the test set. This helps us get a more robust estimate of the model's performance. I'm using GridSearchCV, a powerful tool in Sklearn, to find the best settings, hyperparameters, for my support vector machine, SVM, classifier. It's like a smart search engine for the best machine learning model parameters. I'm testing 3 different values for the regularization parameter, C, 0.1, 1, and 10. Think of C as controlling how much the model cares about making mistakes on individual data points. A higher C means less tolerance for errors, a lower C, more. I'm comparing 2 different kernels, linear and RBF, radial basis function. The kernel determines how the model calculates similarity between data points. Linear is simple, RBF is more complex and flexible. To make sure my results are reliable, I'm using 5-fold cross-validation. I'll split my data into 5 parts, train my model on 4 parts, and test it on the remaining part. I'll repeat this 5 times, each time using a different part for testing. This gives a more robust estimate of the model performance. I have 3 choices for C and 2 choices for the kernel, giving me 3 multiplied by 2, which equals 6, unique combinations of hyperparameters to test. For each of those 6 combinations, I'm doing 5-fold cross-validation. That means I'm training and evaluating each combination 5 times. Because I have 6 hyperparameter combinations and 5 folds of cross-validation per combination, I'll train a total of 6 multiplied by 5, which equals 30, different SVM models. That's a lot of training. I'm using GridSearchCV, a powerful tool in Sklearn, to find the best settings, hyperparameters, for a support vector machine. It's like a smart automated experiment runner. I'm testing 3 different values for the regularization parameter. A higher C value means less regularization and more emphasis on fitting the training data perfectly. Think of it like adjusting the sensitivity of my model. I'm also testing 2 different kernel types for my SVM: linear and radial basis function, RBF. These kernels determine how my model maps data points into a higher dimensional space to find optimal separations. Think of these as different lenses through which I look at the data. I'm using 5-fold cross-validation, which means I'll divide my data into 5 groups. I'll train my model on 4 groups and test it on the remaining group. This process repeats 5 times, with each group getting a turn as the test group. This ensures robust evaluation and reduces overfitting. I'll train my model repeatedly using different combinations of hyperparameters. I'll do this for each fold of my cross-validation. Based on my experiments, I determine how many times my model is trained. I've defined a grid of settings to test. I have 3 values for C multiplied by 2 kernel types, giving me 6 parameter combinations. Since I have 5 folds of cross-validation, each combination is tested 5 times. So, the total number of models trained is 6 times 5 equals 30. I see that we're tuning in SVM, and this grid defines all the combinations of settings I'll try. It includes 3 different values for the regularization parameter, C, 0.1, 1, and 10, and 2 kernel types, linear and RBF. This means we have multiple versions of the SVM which will be tested to find the best performing model. This is one part of the parameter grid, listing different values for the C parameter. C controls the trade-off between correctly classifying training points and having a simpler decision boundary. Smaller values of C lead to wider margins and simpler models, while larger C values prioritize accurate classification of individual points even if it makes the decision boundary more complex. Here, I'm checking out 2 different kernel functions, linear and RBF, radial basis function. The kernel defines how the model maps data points into a higher dimensional space where it can find a linear separating hyperplane. Each kernel has its own strengths and weaknesses, and selecting the right one is an important part of model tuning. To make sure the results aren't just due to random variation in the data, I'm using 5-fold cross-validation. I split the data into 5 parts. Each part will be used as a test set once, while the others are used for training. This gives me 5 different model evaluations for each setting I'm testing, and this will give a sense of how robust a setting is across different data splits. I determine the total number of models trained like this. 3 C values multiplied by 2 kernel types gives 6 combinations of settings. I'm doing 5-fold cross-validation. So that's 6 combinations times 5 folds, giving a total of 30 models. I'll train and evaluate 30 separate SVM models in this hyperparameter search. The technique I'm using to find the best SVM settings is called GridSearchCV, Grid Search Cross-Validation. It systematically tries every combination of settings from the parameter grid, and then uses cross-validation to evaluate the performance of each combination. I then pick the best performing model. I'm training a model using GridSearchCV, a powerful tool in Sklearn for finding the best hyperparameters. It systematically tries out different combinations and finds the best performer. Think of it as a super efficient hyperparameter search engine. I've defined a range of settings to test for my model. This is called a parameter grid. Here I'm changing the C regularization strength and the kernel type to find the most effective settings. These are the specific values I'm testing. For C, I'm using 0.1, 1, and 10. These control how much I allow my model to overfit. For kernel, I'm testing linear and RBF, different ways the model decides boundaries between data points. To make sure my results are reliable, I'm using 5-fold cross-validation. This means that I'm splitting my data into 5 parts, training my model on 4 parts and testing it on the remaining part. I do this 5 times with each part taking a turn being the test set. This prevents the model from overfitting to a particular subset of the data. For each combination of C and kernel values from my parameter grid, I'm repeating the 5-fold cross-validation procedure. Each setting gets tested 5 times to improve the robustness and reliability of the evaluation. I'm determining the total number of models trained. This is the final result, the total number of models trained across all parameter combinations and cross-validation folds. I calculate the number of unique combinations by multiplying the number of choices for C, 3, by the number of choices for kernel, 2. That's 3 times 2, which equals 6. I find the total number of models by multiplying the number of parameter combinations, 6, by the number of folds in my cross-validation, 5. That's 6 times 5, which equals 30. So, GridSearchCV trains and tests 30 different models to find the best one. Awesome.